Welcome to this class. In this session, we will discuss techniques of integration, and we'll start discussing the first basic technique of integration, the so-called the power rule. So let's give the statement and then do some examples. So the integral of a function x raised power n dx is given by x raised power n plus 1 divided by n plus 1, then plus constant c for all values of n not equals to -1. So this is how we state the power rule, that integration of a function x raised power n with respect to x is x raised power n plus 1 divided by n plus 1 plus a constant c. And this rule or this method is applied only when n this power is not -1. Reason for that restriction is because when you make it -1, then the denominator will be 0 and division by 0 is not defined. So that's why you have that restriction. If you relate to what we did on differentiation by power rule, differentiation we were subtracting 1 from the power, but this one now we are adding 1 to the power. And in the differentiation process, we were pre-multiplying the power, yet this time round we are dividing. So the integration problem and differentiation problem, they're actually opposites of each other if you compare the two steps. So problems or examples, evaluate the following. Evaluate the following. So the first problem, A, integral of x power 3 dx, B, integral of x power half dx, C, integral of x power 4 dx, and D, integral of x raised power minus a half dx. So this is our first problem. Now, on the first problem, integral of x raised power 3 dx, we simply add 1 to the power 3, and then once we have the answer, we divide that new power to the expression and then add the constant of integration to the problem. And then the next problem, we'll do the same. Add 1 to that half. After adding that 1, then divide by that new power. Once you have divided by the new power, then you add a constant of integration, similarly to problem C and D. So solution. So I'll say this will be the same as for A, x 3 plus 1 divided by the new power 3 plus 1, then plus C, which is the same as x raised power 4 over 4, then plus C. And this second problem, we say x raised power half plus 1 divided by the new power a half plus 1, then plus C. And then a half plus 1, a half plus 1 is 3 over 2. So this will give us 2 over 3 x raised power 3 over 2 and then plus c. Then this one will have x raised power 4 plus 1 divided by 4 plus 1, then plus constant of integration c, which will be x power 5 divided by 5 plus c. This one will have x raised power minus a half plus 1, you divide by minus a half plus 1, then plus a constant of integration c. Now, minus a half plus 1 is a half. 1 divided by a half, you get 2. So this will give you 2 x raised power half, and then plus c. Next problem on application of power rule, E, if you have integral of x squared minus 2x plus 5 dx, now you just apply integration on each term. So you'll have integral of x squared dx minus 2 integral of x dx, and then plus 5. Now you see when we have constant 5 can be written as x raised power 0. So you have x raised power 0 dx. This will be x raised power 2 plus 1 over 2 plus 1 minus 2 times x raised power. Remember the power here is 1. So 1 plus 1 over 1 plus 1 plus 5 times 0, x raised power 0 plus 1 over 0 plus 1, and then you add the constant of integration c. So this will give us x power 3 over 3. These 2 and 2 cancels out, so we have minus x squared, and then plus 5x, and then plus c. So the answer will be x cubed over 3 minus x squared plus 5x, then plus constant of integration c. And then last example, f, integral of 3x raised power 4 minus 5x raised power 2 over 3, and then plus x raised power minus 3 dx. Now what you do on this problem, you simply supply integration on each term. So we'll say this question will be integral, factor out the constant 3, x power 4 dx minus 5 integral x raised power 2 over 3 dx plus integral x raised power minus 3 dx. So this will be 3 times x raised power 4 plus 1 over 4 plus 1 minus 5 times x raised power 2 over 3 plus 1 over 2 over 3 plus 1 plus x raised power minus 3 plus 1 over minus 3 plus 1 plus constant of integration c. Now this will give us 3 over 5 x raised power 5, and then 2 over 3 plus 1 is 5 over 3. So 5 divided by that answer, we get 3 x 5 over 3 minus, because we have minus 2 here, then minus plus is minus, x raised power minus 2, then plus c. Or we can write it as 3 over 5 so this we have a 2 here because minus 3 plus 1 is 2, minus 2, and then 3 over 5 x power 5 minus 3 x raised to power 5 over 2 or 5 over 3, and then minus, you can write this one as 1 over 2 x squared plus c. If we have another one, integral of 5 over x squared plus 10 x raised to power 4 dx, then you can write this one as integral 5 x raised to power minus 2 plus 10 x raised to power 4, then dx, and then apply the power rule. So you say this is 5 integral of x raised to power minus 2 dx plus 10 integral of x raised to power 4 dx. So this will be 5 times x minus 2 plus 1 minus 2 plus 1 plus 10 times x raised to power 4 plus 1 over 4 plus 1, and then plus c. You see minus 2 plus 1 is minus 1, so we'll have minus 5 x raised to power minus 1 plus, this will be 5, this will give us 2 x raised to power 5 plus c, and you can write this one as minus 5 over x plus 2x power 5 plus c. So that's how we apply that power rule. And then just from what you have been doing here, some basic rules. So the integral 1, integral of a sum of two functions f of x plus g of x with respect to x is the same as sum of the respective integrals. And then number 2, integral of difference of two functions is the same as the difference of the respective integrals. Number 3, integral of a constant times a function f of x with respect to x is the same as you factor out the constant, then carry out integration of the function with respect to x. So those are some of the basic tricks that you can use to simplify the indefinite integrals when you're applying the power rule, and even other rules when you have a sum, a difference, or a constant times a function. Thank you.